Starting our P6-10 drawing, you can either use the standard drawing template or the template that you created. If we start with the model view, I will browse to the assembly and open. And we can place the isometric view. And my origins are still on, so we'll go to the view and uncheck the view origins. We can then Control C and Control V and go to the properties for that view, show an exploded state. We'll see the exploded sketch. Might make some adjustments to that so it's a little more visible, but it's a good start. And under the annotations, we'll go to the auto balloon and kind of go through. That one looks pretty good. I drag down to the layer, I'll apply the dims layer just so that we have a little bit of contrast. And hit OK. Alright, so that's looking pretty good. We'll right click and go to the tables and to the bill of materials. And we have a standard bill of materials. And at this point, I don't believe I have any properties to work from, so I'd like to change this to the part number. So I've kind of previously modified the C blocks and the assembly. So PVA03, well, we'll just leave this plain carbon steel. Remember, you can edit the material and pick just about anything you want. It's going to ask you to save. Revision A. We'll leave this as a raw, modeled by, and set. So once I apply that and save it, now I'll be able to go back to the drawing, so we can just close that. And we have the part number, but really that's the part name, so change that. And then under the description, because now the one of the elements in here has those custom properties, I'll be able to pull up the part number. All right, so PVA02. And if we did that, the part number for the component in this drawing is PVA01. So I have that kind of traceability or that associativity going on. If we'd like to add something like the material, and we can do different bills of material. So if I insert a column right and then go to its property name, we'll pick the material and expand that out a little bit. So just kind of like Excel, if I double click, it's going to expand the cell to make it look pretty good. So right now we don't have a whole lot of cell padding, so maybe we'll go up to, let's see, that's 0.2 inches, so that's a little bit too big, maybe 50 thousandths. Okay, so that gives it a little more separation. And could do that on all of them if we needed to. Alright, so if I want to reuse that that bill of material on future, I'm going to do a save as, and we've gone over to the templates. We'll go up one level since I'm kind of accumulating there, and we'll stay with my naming convention, my BOM. Alright, so as we go back through, I can right click and open the pivot, and this will be just doing pivot arm 04. Material is going to stay plain carbon steel. Finish raw. Apply and save. And then we could also do this out of, I believe, the assembly. Once that's highlighted, I can tell it to open, and it'll tell me the lock pin. So I know I've picked the correct item. And we could also do it out of the feature tree in the assembly over on the right. PVA 05, stay with material. Put in our information, apply, save, and close. Alright, so that gives us the assembly, kind of gives us a sense of how this is going to go together. We'll add in the next sheet. So I keep having the phantom surface finish symbol pop up, so let's edit the sheet format. And I'll delete it out of there. And let's go ahead and save the sheet format just in case. So I double checked that under the options that it wasn't something that was carrying over from the document template, that the multi-sheet property source is unchecked. And let's go ahead and hit the next one. Alright, so it cured it for now. And the other thing would be to go into the properties, and I tried to reload, but it doesn't seem to be a reload issue. So if you see those, that's one of the, that's just going to be the diagnostics that we have to deal with. So we've got the drawing name, we've got the drawn by. So at least for this time I've taken care of those. So I'll put my initials in, give it a drawn date of today, and apply it so that those show up in the title block. And then we'll go back to the view palette. Haven't selected anything, so I'd like the C block. So again, my first pass on this is going to be to get my drawing views picked and set. Don't know that, well, we might need the side view. That might be descriptive enough. Yeah, we'll need the side view and then an isometric. So we'll go ahead and accept that. Put that over a little ways. If I turn that to custom scale, when I go over to the sheet scale and make it 1:1, that will give it a little more room. We'll go to sheet 3, and if I stay with the view palette, we can just go pick, and we'll probably go with the arm next. I should only need 2 views with the arm, so definitely the top. And then we'll drag out a little bit to the side, put in our isometric, and OK. So same thing, I can use the custom scale. We'll go from 1/2 to 1:1. Reposition a little bit. And then we have the 2 pins. So if we go with the pivot pin first, and let's go with the top. I don't know that there's anything. Well, we'll go ahead and put it in. Did not project the way that I was expecting it to, so back into the drawing, projected view. Make sure we get the bottom. And scale-wise, that looks pretty good. Oh, I missed the isometric, so if I right-click, let's see. Just going to see if it was available. I'm not quite seeing it there, so we'll just go back to the drawing, projected view, pull up an isometric. I could also have come back to the view palette now that I think about it and picked an isometric, which either one of those looks pretty good. And then the last one will be the the lock. So grab the lock pin. And we'll just stay consistent. I don't know, this one needs the other view. Okay. And we can accept those. Alright, so our first pass completed. Then we'll go back and start putting in dimensions. And again, you design for convenience and you detail for manufacturers. So, since I'm not in the DIMS layer, we'll go ahead and pick the DIMS so that anything I'm applying here will get that and I won't have to go back. So 2.05. And if this was a critical dimension, I would probably prefer it to the other. So we'll go that way. We have our width, and then we have a height. And we'll just keep locating these. Alright, and then for the whole wizard callouts, actually there's one more there. We have the through. And so this is one of those cases that the hidden lines will add some to the description. So if I pick on this view and go back to hidden lines visible, it will update the child or the aligned views as well. And then that one really didn't pull up. Well, we can see what it looks like with the whole callout. We'll grab the M12. And then go grab the M10. And I guess that's going to need an additional dimension there. Okay, so those are pretty good. We've got the H values based on our thread callouts, since those are in metric. Go between the two. If we give it the width, then we might just go with the full R. So in that case, I can get rid of the dimension, so that we're pretty much just calling out the radius to blend. It gives a good clearance to manufacturing. Back into the annotation, we'll go ahead and use the callouts. Another smart dimension for the thickness. In this case, I don't think the hidden lines are going to add a whole lot of value. Alright, and then I'm not, I don't know that the square notation really helps much there, so I would just as soon dimension it to the value. And if we're coming off of that end, and then the overall. So if you haven't gone back through and added the cosmetic thread, then we're not going to really have that that call out. And usually it puts in something, but you can get it. So I don't think I can do the whole call out here. It's just going to find that information. So the whole call out doesn't do our external threads, so we'll go back into the smart dimension, and then I just have to be careful to pick on the cosmetic thread and we'll get the M12 by 1.5 machine threads. A little too much notation, but it is functional, so we'll go with that for now. And maybe move that up a little bit, give it some more room. So our diameters then, we can go back to the Smart Dimension, find the OD. And the M12 gives that, the diameter of the threads. And then we have the dimensions for the square. That will work. And then this one did not get a cosmetic thread, so let's see what that had for a length, 15. So let's go ahead and add that just for a reference. So this gets added to the part, and we'll find that leading edge, insert annotations, and then when I'm doing this a lot or enough, then I will just add the cosmetic thread up to probably the sketch. All right, so machine threads, M10 by 1.5. Don't remember what I called the hole out now. We'll go back to that drawing, but this is part of the validation of the prints. Each time we go through an iteration, we're looking for those general anything that kind of comes up. So in this case, I think the view, I think we probably grab that, but it's going to be confusing. So on the view, since that is the top, if I were to switch it to the bottom, then I get the center mark. Well, I guess that brings up my center marks. Let's go into the Smart Dimension, make sure I'm on the cosmetic thread. So that one's the 1.5. We'll go back over to sheet 2, and the back is 1.25. So that being the case, I want to make sure that those line up. So I'm going to expand out, find the cosmetic thread, edit the feature, and then make sure that it's a 1.25. And can save that and close it. Alright, so that looks pretty good. I didn't get the chamfer in there, so let's go with an overall. It does not give the depth, and since in this case the machine threads are a little bit different, let's go ahead get rid of that. Smart Dimension 0.39, and the OD of the threads would be a little more controlled. So we have the depth, and then to put a chamfer, go into more dimensions, the chamfer dimension, pick those, and I reverse the order. So more dimensions, chamfer, we'll pick the chamfer first this time, and then one of the horizontal. Go to fit. Alright, so we're ready to go back through and see what we missed, do some minor format, what looks good. If I highlight the center marks, go to the center. This one could probably be a 1-to-1 with 1/2 for the part. I don't think I've saved yet, so we'll save the document. And this is in the correct, so the pivot arm. So it'll share pretty close to the same name as the assembly. So center mark. If I needed to add, more for reference than anything, if I needed to add a center line through the body of the part, and that kind of, I didn't really do that there as far as controlling the position of that square. So right now it could technically move around. So if I wanted to add a center line, go through and pick the view, get out of that. I could also draw in a center line, but the center line tool is pretty handy. Then we'll just stretch that out a little bit. So I think if we grabbed the view, it would have picked that up. All right, so a few more. So we'll turn on the filters and filter for the center marks and change those. I think everything's pretty good there. I'll need to look up the actual specification on the using the full R. And then center mark, and I'll just hold down the control, go into the center mark, and OK. Alright, so the next pass would be to do the tolerancing, checking for any of the items that we would want to hold a little bit closer. And so if the 2 decimal place is good for most of these, which is going to keep it at stock material, but then the holes and the through holes may want to go to 3 decimal place. Or if we're kind of moving towards reaming this geometry, we would take into consideration that maybe this is a 472 12 millimeter ream. Then when we were controlling this 472 or 5, whatever it was, 550, that's got plenty of clearance though, so that's not quite a good example. But if we were looking at this pin being a tight fit, then we would want to look at adding the tolerances, a slight plus tolerance to a minus tolerance on the shaft, so that we end up with that clearance fit. So there's not really too much here, and not knowing what it connects to or how it mounts, I think we have a pretty good drawing going, and we'll come back and analyze if we need to.